In the previous video, we talked about the average rate of change of a function over a certain interval from a to b. In this video, we're going to talk about the instantaneous rate of change of a function f at a point c. And we define the instantaneous rate of change at c to be just f prime of c. Now notice that's just the slope of the tangent line at c. So let's look at a function here, f. Now at different points along the curve, the function is changing at different rates. So for example, at this particular point, the function is changing at a certain rate. Whatever the slope of the tangent line is at that point, that's the instantaneous rate of change of the function. Now notice a point like right here, it looks like the function is decreasing, right? It's going down, so it would have a negative instantaneous rate of change. Or right here, it's a little steeper. Okay, it's still a negative slope, but it's a little steeper, so it would have a bigger negative number as the instantaneous rate of change. So let me draw in a particular value here. Let's draw it in blue. At this point here, the slope of the tangent line there, right, f prime of c would represent the slope of the tangent line. That's the instantaneous rate of change of f at x equals c. So notice we're not talking about how the function is changing over an interval. We're talking about how is the function changing at one particular value, okay, at x equals c. So let's look at an example. Find the instantaneous rate of change of the function f of x equals 1/2 x cubed minus x squared minus 7/2 x plus 10 at x equals 1. So what we really need to find is what's f prime of 1. Now f of 1, just in case you're wondering, f of 1, if you plug it in and work out all the details, f of 1 ends up being 6. Okay, but that actually doesn't matter for the rate of change. That just tells us that the graph has a height of 6 at x equals 1, or in other words, the point 1 comma 6 is on the graph. The question though is what is f prime of 1? So what's first of all f prime of x? F prime of x would be, well, we have to do 3 times 1/2. That would be 3/2 x squared minus, well, the derivative of x squared would be 2x. The derivative of 7/2 x is just going to be 7/2. And the derivative of 10 is just 0. So there's f prime of x. Now what is f prime of 1? Well, let's just plug in 1, right? We get 3/2 times 1 squared minus 2 times 1 minus 7/2. So that would just be 3/2 minus 2 minus 7/2. And we could get a common denominator here. Let's get a common denominator of 2. Notice that 2 is the same thing as 4/2. So we have 3/2 minus 4/2, that'd be negative 1/2, minus 7/2, which would be negative 8/2. Now negative 8/2 is the same thing as negative 4. So the instantaneous rate of change of this function at x equals 1 would be negative 4. Now graphically, what does this mean? Well, let's go to Desmos. Here's the graph of that function, f of x. And our point, 1 comma 6, is the point on the graph here. And again, that just means that f of 1 is 6, or the height of the function at x equals 1 is 6. The question, though, is what is the slope of the tangent line at that point? And it turns out when we figured it out, the slope was negative 4. And notice that looks reasonable here. It looks like that blue line could have a slope of negative 4. So the way we found it was to take f prime of x and then plug in 1. So we found f prime of 1 was negative 4. And that is the instantaneous rate of change of the function at x equals 1.